Okay, so what we discussed in the last class? Very basics about mole concept we started. I mean, started from very scratch, that is matter we discussed, right? So again tell me, matter classification, like basic definitions and all. Like matter is anything that has some mass, occupies say space. This story we discussed. Then its classifications, like matter can be pure form and it can be impure form. Okay, and this pure form further divided as elements and compounds. Again elements are further divided as metals, non-metals, metalloids. Okay, yeah. So compounds are formed by combination of two or more elements in the fixed ratios. Some examples for compounds you can give: H2O, methane, CO2, glucose, all these are some examples. Okay, next, mixtures are again two types. One is homogeneous, other one is heterogeneous. Okay, homogeneous and too much, huh? Mixtures are two types. One is homogeneous, other one is heterogeneous. Okay, homogeneous means how can you understand in a simple way? Should have a uniform phase throughout the mixture. Means like you are adding sugar to water, gives a uniform clear solution. So if it's a clear, we having uniform throughout the solution, you can say it's a homogeneous. Okay, next, if there are distinct phases, for example you are adding oil to the water, so it won't mix together, like they are immiscible we can say. Okay, those are immiscible liquids. Okay, so if two immiscible liquids are there, you can say it as a heterogeneous. Okay, and two physical states are also separated, means also heterogeneous. You are adding sand to water, what happened? Sand separated, water separated, it's also heterogeneous. Then next, some examples for heterogeneous I told you: oil in water. Okay, the next one is colloids are the best examples. Okay, next, homogeneous means generally whatever you are taking in our daily life, like metal alloys are also can be considered as homogeneous. Alloys are made up of what? Two or more metals. Okay, they will also form homogeneous. Okay, solution doesn't mean it should be in liquid, it can be gaseous phase, liquid, or it can be solid phase. Okay, for solid solutions alloys are the best examples. For gaseous solutions, air is the best example. Air is a mixture of different gases now having uniform phase. So that one. Next, for liquid solution you take any two liquids like alcohol, water, this kind of things. Done. Then next, today we will slowly enter into calculations of mole concept. I mean, what do we mean by mole first of all? This basic idea should be there. So mole is nothing but, it's a term used in chemistry to define or to express number of particles. Like for example, I am giving 5 grams of a substance. 5 grams of a substance means it has lot of atoms. Many atoms are there. So to express number of atoms, that microscopic properties are there, microscopic species are there now, like atoms, electrons, these things. Even if you take small quantity, there will be lot, like crores, millions, 100 millions, like that we will be having n number of particles like atoms and electrons, the subatomic particles. So in order to express that minute particles, we will use a simple term called a mole. Okay, so mole is a term used to express quantity. For what purpose we are expressing? Quantity or number of entities, number of particles, similar to something like a dozen. Dozen means you are saying it as 12, no? So same to this, in chemistry we will use the term mole. Okay, so this is nothing but, here we have a fixed number as 12, no? So in chemistry we have 1 mole means 6.022 into 10 power 23. So by default you should get 1 mole means this many number of atoms or particles, whatever they are asking. Okay, so now if I give you 12 grams of carbons. 12 grams of carbon I am giving you. 12 grams of carbon atoms or whatever. Like I am giving you a piece of coal. What I am giving you? Piece of coal. It weighs 12 grams. Now in the 12 gram piece, how many carbon atoms are present? This is the question. So how to solve this? Okay, so there is a concept, like if I know 12 grams means how many moles, then I can say how many atoms are there, because if it is 1 mole, I can say it is 6.022 into 10 power 23 carbon atoms are present. So what is my primary criteria? Convert the given weight to moles, then you can able to express how many atoms, right? Yeah, so now I am doing that. Yeah, so there is something called mass spectrometer. What I am saying? Mass spectroscopy or mass spectroscopy or metry. Okay, so what is the use of this spectrometry means? It will be used to identify the number of particles in a given substance, in a given amount of substance. Okay, so now what they did is, when we go to like market, what we'll do, we'll ask the market shopkeeper to give like 1 kg of tomatoes. What he will do? He will put one iron piece one side as a 1 kg, the other side he will put the tomatoes and he will weigh and give us. So similar to this, we need a standard quantity to express the weight of atoms also. That standard quantity is nothing but C12 carbon. What they have considered? C12 as a standard quantity. So this C12 carbon, they have taken 12 grams. How many grams they have taken? I mean C12 carbon they have identified. Okay, so they found C12 carbon of 1 mole substance they have taken. Okay, so it is nothing but 12 grams. How many grams it is? 12 grams of C12 is nothing but 1 mole. I'm not complexing it, I just wanted to summarize it in a simple, short and sweet manner. Like 12 grams means how many moles they got? 1 mole through this instrumentation. Okay, yeah. So whenever I say 12 grams of carbon, what you should blindly fix it? 1 mole. So how they got this as 1 mole? Because when they taken it as 12 grams, they get it as 1 mole, and they have taken it as 6 grams, they got it as half mole. How many moles they got? Half mole. When they have taken it as 3 grams, they have got some other number here. So how they are getting all these things? Okay, so just see, I want how many moles it is. I want how many moles. So simply see, number of moles I can find, number of moles I want. This is nothing but 12 into n equals to 1 into 6. That means 12 grams 1 mole, 6 grams how many mole? This is my question now. So simply use the unitary method. So n into 12 equals to 6 into 1. That is nothing but 6 by 12. 6 by 12. So now what is this 12 actually? When it comes to carbon, what is this 12 actually? Here you are seeing something like 12. So 12 is nothing but its molar mass or molecular weight. Okay, so I am defining two terms now. One is molecular weight, other one is molar mass. So molecular weight is atomic weight, molecular weights, these are nothing but, if I say atomic weight, this is an atom now. When I say atomic weight, it is nothing but sum of its number of protons plus neutrons. So carbon atom contains how many protons? 6. And how many electrons? 6. So here when I considering mass, do not worry about mass of electron, because mass of electron is very less, we can even negligible when I compare with the mass of protons and neutrons. Okay, now here the number you are seeing it as 12. What is this 12 indicates? Mass number of carbon. So it means carbon contains 6 protons as well as 6 neutrons. So overall sum is 6 plus 6, 12. Okay, so that is its atomic weight. Okay, so now even the molar mass is also 12, but you should express that in terms of grams. How you should express? In terms of grams. Sir, why in grams means, so if you consider 12 grams of carbon, how many atoms we are finding? 1 mole of carbon we are finding right now. So the mass of 1 mole of substance is called its molar mass. What is the simple definition of molar mass? Mass of 1 mole of any substance is called its molar mass. So here 12 we got na, that is nothing but molar mass of carbon, molar mass of carbon. And what I am asking, number of moles of carbon only. Okay, so now here what we have written, the given weight. So we made a formula now, weight of a substance by molar mass of that substance gives you number of moles. So simply we got a formula like number of moles is equals to given weight of the substance by gram molecular weight or molar mass, both of them are same. Okay, a simple very fundamental formula we got, number of moles equals to given weight by molar mass. So just see this thing, number of moles equals to, what is the given weight? 6 grams, molar mass 12. Okay, see molar mass, name itself saying molar mass means mass of 1 mole of substance. So gram per mole, mass of 1 mole of substance is molar mass. So units of molar mass is gram per mole. So gram cancel, it is 2 times. So 1 by 2 mole you can write, or half mole you can write 0.5 mole. Is this clear? Okay. So simply whenever they express in the quantities, like given weight of a substance is provided. Now they are asking you to find number of moles. What is the best way to do? Given weight of that substance by molar mass of that substance gives you number of moles. So this simple formula you can note. Okay. Next. So for example, I think you know how to calculate its molecular weight. Tell me how to calculate. No. For carbon it is 12 plus 4 into 1. So it is 16. This is very simple. So molar mass means 16 gram per mole you can express. Now I am giving you a question like this. 0.4 grams of methane is given. Then number of moles of methane, number of moles of methane. So find this. Done? Yes. How to find? Number of moles of methane is equals to weight by molar mass. Yes, tell me. 0.4 by how much? 0.025. So how to simplify these?
4 by 10.
So you can write this as 4 into 10 power minus 1 by 60. So this will be 1 by 4. 1 by 4 means 0.25 into this 10 power minus 1 means 0.025. Hope calculation is simple, you can do. Yeah. Next one, giving you for the same question I can ask you like this: number of moles of hydrogen atoms in the same quantity. See, how many grams of methane is given? So how many moles of methane we got?
0.0.
This is fine. Now my question is, how many moles of hydrogen in 0.4 grams of methane? Try once. Yeah. So I will tell you this one. If you want, you can do the next question. Yeah. So first of all, in methane, in one methane molecule, how many hydrogens are there? So it means 1 mole contains 4 moles of hydrogens. 1 molecule of methane contains 4 hydrogen atoms. Then 1 mole methane contains 4 moles of hydrogen atoms. Is this clear or not? Fundamental thing. So this number is there now. What we can say it as atomicity. What is it? Atomicity. So what is the atomicity of hydrogen?
4.
And carbon? 1. Like that. So if they ask number of moles of hydrogen atoms in that methane. So given number of moles, like number of moles of methane you take, multiply that with atomicity of that element. Which element they are asking? Hydrogen. Atomicity of hydrogen. That means 0.025 into 4. So you can do that. Okay, is this clear what we are doing? Okay. Now write a question. Given 90 grams of glucose formula C6H12O6. Given 90 grams of glucose. Then calculate number of moles of glucose and also number of moles of hydrogen atoms, number of moles of carbon atoms. Done. First, what to do? Given weight, first number of moles of glucose. Given weight is 90. What is the molar mass of this? 180, because 6 into 12 plus 12, 6 like 12 hydrogens, 12 into 1, 6 oxygen, 6 into 16. So it is 180. So from now onwards, no need of calculating like this. Just remember glucose molar mass is 180. Okay, because we will use it regularly. Okay, 180. So here also grams, here gram per mole. So gram 90 means 2 times. So how many moles? Half mole. Half mole of glucose is given. This is fine. Next, what I am asking? Moles of hydrogens. Find it.
6.
How many moles? Yeah. So it's very simple. Moles of hydrogens, if I say, moles of hydrogen atoms I am saying now. First, you know, in glucose, in one glucose unit, how many hydrogen atoms are there in one glucose unit? So number of moles of glucose units, number of moles of glucose into atomicity of that element. Which element we are talking? Hydrogen. So hydrogen. So it is half into 12. 6 moles of hydrogen. Is this clear? Yeah. So next, tell me number of moles of carbons, because C6 now, so 6 into 1 by 2, 3. Done. Now these are moles. If I ask number of carbon atoms, that number of moles into Avogadro number, that 6.022 into 10 power 23. So you got number of moles of hydrogens. Similarly, number of moles of carbons means in glucose, in one glucose unit, atomicity is 6 for carbon. So this is 1 by 2 into 6. See, this is 3 moles of carbon atoms. So mole, in the place of mole I can write, in place of moles I can write Avogadro number, that is 6.022 into 10 power 23 carbon atoms. Okay, simplify it, just 18 into 10 power 23 you can write. Done. Okay, yeah. So this is a very basic model questions first. Yeah, next one. So one basic relation we got is weight by mass by molar mass equals to number of moles, and 1 mole contains Avogadro number of particles that we can indicate with Na, that is nothing but 6.022 into 10 power 23. If we got these 2 relations, right? Okay, next one I am asking a question, just see. Okay. Like if I say 5 moles of CO2 is given, then weight of CO2. What is the weight of CO2? So those who are in the comment, live watching, you can mention your answers in the comment box. Yeah. Any answer? So what I am asking? 5 moles of CO2 provided, weight of CO2 I am asking. So basic relation between moles and weight? Weight by molar mass. What is the molar mass of CO2? 44. N into molar mass. Number of moles into molar mass gives you weight of the substance. Okay? Yeah. So from this 5 into 44. 220 grams. Done? Now just a small question, no need of pen paper also. 5 mole CO2 contains how many moles oxygens? 5 mole CO2 contains how many mole oxygens? 10, because 1 CO2 contains 2 oxygens, then 5 mole means 5 into 2. Done? Yeah. Next. So I am giving you next. So questions can be like this. Either they give number of moles, ask for weight, or they give weight and ask for number of moles. Okay? Or they may give weight and ask for number of atoms. Let us see one more question like that. Okay. So I am giving 4.4 grams of CO2. Then calculate number of CO2 molecules. Number of CO2 molecules. First, what to do? Find number of moles. Any answer? Yeah, easy. Just see. Number of moles you find first. Because if I know 1 mole, like in number of moles, then I can multiply with Avogadro number. Find number of moles by 44. Given weight by molar mass. That's it now. So it means 0.1 mole. So multiply 0.1 into 6.022 into 10 power 23. So it is 6.022 into 10 power 22. Okay, that's it. Done up to here. This is very basic models. Next, one more connection we have. We'll go with that. Yeah. So till now we discussed weight to moles, moles to weight, and moles to Avogadro numbers, like number of particles, number of atoms, entities I am saying, entities. It can be atoms, electrons, anything. If I only write atoms, it won't suits good. It can be electrons also sometimes. Okay? If they give number of entities, we can find number of moles, then calculate. Okay. Now, let me give you one question on this. With this, we can go forward. Okay. Given 3.011 into 10 power 20 methane molecules. Calculate its weight. Just look at this. What I provided in the question? number of entities, like number of molecules provided, then calculate number of moles, then go for number of, weight of that substance. కొంచెం once again,
No, I'm asking the answer. I'm asking the question.
10 power 20 only. The basic relation is 1 mole. How many particles? Like how many molecules? 1 mole of any substance contains Avogadro number of particles, Avogadro number of molecules, you can say. 1 mole methane means Avogadro number of methane molecules. That big number we will write later. First you write like this. Next, given question contains 3.011 into 10 power 20. So how many moles? How many moles it is? This is my question now. Let us go back. Okay. So what you need to do is use the unitary method. Avogadro number into this one into 1. So finally you will get number of moles of methane is equals to 3.011 into 10 power 20 by Avogadro number. So the standard formula for this to remember is number of moles is equals to number of entities given by Avogadro number. Like see, in the denominator what we are seeing? Avogadro number. Numerator what we seen? The given number of entities. Given number of entities in the numerator. So Avogadro number here 3.011 10 power 20 by 6.022 into 10 power 23. So this is 1 by 2. This one 10 power 3. So this is 1 by 2. It means 0.5 into 10 power minus 3 mole. Minus 3 moles. This many moles. Or you can simply write 5 into 10 power minus 4 mole. Okay, up to here it is fine. Now my question is not about moles, so I am asking about weight. So now number of moles is there. How to find given weight of substance? Number of moles equals to weight by gram molecular weight. I am asking weight.
Moles into
Molar mass. Just do that. What?
18 to 10 to the power minus.
Okay. That's it. So weight of methane means N into molar mass. 5 into 10 power minus 4 into 16 moles into what is the weight of molar mass of methane? 16. Okay, 16 5 so 80 into, so 8 into 10 power 3 grams. That's it. See, even if you take small quantity of substance, we have this many number, like a very big number of molecules are there. Okay, so that's why in order to express number of entities, we'll use the concept as 1 mole. Okay. Now, what you studied till now, let's make some clarity out of it. First, if weight is given, you know how to calculate moles. What you did here? Divided the given weight with molar mass. If moles only given, you can find weight. Now what you did here? Multiplied with molar mass. This clarity you have now. Okay. Sometimes they will give you number of moles and ask you to calculate number of entities. Number of entities. How to do this? Given moles multiplied with Avogadro number. You have multiplied with Avogadro number. Like 1 mole, Avogadro number. 2 moles, 2 into Avogadro number. Like that. 5 moles, 5 into Avogadro number, that we seen. Okay. But sometimes, like in the previous question, I given number of entities. Then how to calculate moles? Here we got now given number of entities divided by, so divided by Avogadro number. If you know Avogadro like number of moles, then we can also convert into given weight also. That is what we did here. First, what I taken number of entities given by Avogadro number, I got number of moles. After finding number of moles multiplied with molar mass, we got weight of the substance. Okay, this clarity you have now. Any confusions are there in this? No. Yeah. Next, there is something called Avogadro law. Avogadro's law or Avogadro's hypothesis. So what he found is at same temperature and pressure. At what? At same temperature and pressure. Any gas of equal volumes. This is an experimental observation. What he found it, at same temperature and pressure, he taken different gases. That's why I am saying any gas of equal volume. For example, I am taking 1 liter of O2 gas here, and here 1 liter of N2 gas, or whatever the gas you want, you take. So whatever the number of particles present here, same number of particles will be present here. It means, let us say 1 liter of O2 contains some 1 lakh particles, 1 lakh oxygen molecules. Then 1 liter of N2 also contains 1 lakh N2 molecules. Is this clear or not? So what it is, at same temperature and pressure, any gas of equal volume contains equal number of gas molecules, or whatever it is, atoms or molecules. Okay, depending on the question to question. Here it is molecules only. Okay, clear what we are discussing? Okay, if I say 1 liter of O2 contains 1 lakh molecules, then 1 liter of N2 also contains 1 lakh molecules. Okay, so you can remember it is V is directly proportional to N. At what? Constant pressure, temperature. So he observed something more interesting than this. What he considered is, he taken 1 mole of a gas. What he considered? 1 mole of a gas in a container. 1 mole of a gas in a container. At what conditions? Means at NTP conditions. At what conditions? At NTP condition. This condition is important because temperature, pressure must be fixed. It means they should remain constant. So at this normal temperature and pressure condition, 1 mole of a gas is found to occupy 22.4 liters of volume. How much volume it is having? It means the volume of container is considered as 22.4 liter. So in that, how many gas particles he have observed? 1 mole. So 1 mole is nothing but our Avogadro number. Okay. So but this condition at what? Normal temperature and pressure. Okay. So this is nothing but 0 degrees Celsius and 1 atm pressure. Okay. Yeah. So all the time just now remember like this, 22.4 liter of a gas at NTP. If they mention, what should be the thing in your mind? It is nothing but 1 mole of a gas. 1 mole of a gas is nothing but its weight equals to, yes, 1 mole weight by molar mass. So if it is 1, weight will be equals to molar mass, right now. So 22.4 liters of a gas at NTP is nothing but 1 mole of that gas. That is nothing but the weight of the substance will be molar mass. That means it is equals to, weight is equals to molar mass of the gas. So what is the weight of 22.4 liters of N2 gas at NTP? I am asking. What is its weight? What is the molar mass of N2? It's 28. So 28 grams. So this quantity weighs 28 grams. You can understand in that way. Okay? Yeah. Next thing, we'll make some questions on this anyways. Yeah. Also you can link it to Avogadro number of particles, because by knowing how many moles, multiply that with Avogadro number simply. Okay, let's do some questions on this. Given 11.2 liters of H2 gas at NTP, calculate weight of H2 gas. Calculate weight of this H2 gas. So whatever may be the thing they are asking, first convert volume to number of moles to given weight. Okay, I will tell you if you want this. Okay, you just write this first. Avogadro's law, all thing, this thing is written. Just make a note of it first. Question I will explain. Next you can solve. Okay. First of all, we know 22.4 liters means at NTP. That condition must be there, ma, NTP. Okay, so 22.4 liters means 1 mole of that gas. 1 mole of which gas they are talking about? Mole of H2 gas. Okay, at this condition only. Condition changes, quantities also changes. Okay, now given 11.2 liters at NTP, then number of moles of H2. Find that number of moles of H2 means use the unitary method, N into this into that. Finally we will get NH2 equals to 11.2 liters by 22.4 liters. This is nothing but we made a formula now from this discussion. NH2, like number of moles of a gas, is equals to denominator all the time this number only. Okay, 22.4 liters like there. Here given volume. Okay, these conditions should be at NTP. Okay, now simplify this. Half mole. Now mole we got now, then you can calculate weight. How do you calculate? Moles equals to weight by molar mass. Weight means N into mm. So moles are 1 mole, half mole, molar mass of H2 is 2. So this is 1 gram. Clear or not? Okay, grams of H2. Okay, next few more questions I will give you, you just solve. So when it comes to physical chemistry, it's not a theory. You need to solve maximum number of questions only with different approaches, different models. This is clear now, first of all? Okay, now write a question. 5.6 liter of CO2 gas is given at STP. Find its weight. Just write it as NTP only. We will discuss about this STP later. Done? 11 grams. First, what to do? From the given volume, calculate number of moles. Then calculate weight of the substance. So, number of moles of CO2 will be given volume by volume given at NTP by 22.4 liters. So that is 5.6 liters and 4 liters. So this will be 1 by 4 times. Okay. So 1 by 4 mole we got. Okay, 1 by 4 mole is nothing but weight by molar mass. Then weight will be CO2 into molar mass. That is 1 by 4 into 44 is a molar mass of CO2. So this is 11 grams. Clear? Okay. So whatever the model questions we did, there are many questions like these are simple questions actually in mole concept and in the exam also. So you should not skip these or you should not get any mistakes, errors in this type of questions. Okay, done up to here? Okay, next. So finally, let's conclude our discussion of this mole concept. First thing is mole. We linked this mole with weight. Then also linked this with number of entities using Avogadro number. Then I have linked this with volume at NTP. Yes. So in order to get moles from weight, what I should do? In order to get moles from weight, divide this with molar mass. In order to get weight from the given moles into molar mass. So why I am making you to write multiple times, so you can revise them. Yeah, moles to entities. What we did here, multiplied with Avogadro number. If they are asking atomicity of particular element, then multiply that atomicity also, depending on the condition. Okay. Next, entities to moles, divide with Avogadro number. Next, if number of moles is given, volume asked. Number of moles is given, volume asked. 1 mole 22.4, 2 moles 2 into 22.4 means what? Given moles is provided means multiply that with 22.4, because see 1 mole is nothing but 22.4 liters. Okay, 2 moles means 2 into 22.4, n moles means n into 22.4 right now. So number of moles given, multiply this with 22.4 liters at NTP condition only. Okay, if volume only given, divide this with 22.4 liters, then you will get number of moles. Okay, yeah. This is a summary of the discussion that we did till now. Okay, let's see some PYQs on this. If you followed the class clearly, you can very simply or very smoothly you can do them. Yeah, done this? Done with this? Yeah, let's solve this question. Do this. Yeah, any answer? B, huh? What is the question? Number of oxygen atoms. This model we did. See, number of oxygen atoms in 4.4 grams of CO2. First, what to do? Moles of what? Yes, perfect. NCO2 you find. Given weight? 4.4. What is the molar mass of CO2? 44. Gives you 0.1 mole CO2. 0.1 mole CO2. So they are asking number of oxygen atoms. Okay, it means 0.1 mole means Avogadro number of CO2 molecules are there. This many number of molecules are there. So in one molecule of CO2 contains 2 oxygen atoms, right now? That is what atomicity of oxygen. So 0.1 into Avogadro number into 2. What is the 2? Number of oxygen atoms. So number of total number of oxygen atoms is equals to this many. So it becomes 0.2 into 6.022 to 10 power 23. So I can simply remove this 0, or if I want I can write it as 1.2 into 10 power 23 also. Do we have anything like that? First option. Clear what we are doing? Yes. Did we discuss this model or not in the previous sessions? I mean, in the okay. Now I am asking number of carbon atoms. So for this, B. Okay. So do you want one more similar kind of question? Yeah. Now I am asking .4 grams of methane given. Methane given. Try to solve in a proper way. 0.4 grams of methane given. Calculate number of hydrogen atoms. Yes, you can try. First, don't get confused. Be clear. What is the data provided? How can I connect it to the number of atoms? Clear with the data. So first, given data is weight. Convert into moles. Convert into atoms, I mean particles. Do this first. Why you are struggling? So tell me how to solve. First, number of moles of methane. Given weight, molar mass 16. So So how can you write this? Simply 4 into 10 power minus 1 you can write by 16. So this will be 1 by 4 times. So this is 1 by 4 into 10 power minus 1 we have. So 1 by 4 means, just now I told you take 4 here, 1 here, put a decimal, 10 it becomes, 4 2s are 8, okay, 2 we are having, okay, then next 0 if you put 5s are 20, okay, so you can write 0.25 into 10 power minus 1. 10 power minus 1 is nothing but 1 by 10. So you can write this as 0.025. Okay, yeah, done. Moles we got, but I am not asking about moles. asking about hydrogen atoms. So number of methane molecules we got, methane moles we got. Okay, yeah. Next, what to do? So number of moles of methane is 1 by 4 into 10 power minus 1. I am writing. Okay, into Avogadro number I can write, so that I will get number of methane molecules. Okay, in one molecule of methane, how many hydrogens? 4 hydrogen. That is what atomicity. So number of hydrogen atoms, if asked, this many moles, like this many molecules of methane into its atomicity. 1 by 4 into 10 power minus 1 into Avogadro number into 4. So this 4 get cancelled. Finally, Avogadro number means 6.022 into 10 power minus 10 power 23 into this number. So it is simply 6.022 into 10 power 22 is your answer. Any mistakes? Or if the same question is asked for total number of atoms, చేయండి. How to do? Total number of atoms means what, ma? In methane, how many atoms are there? That's it. That many moles into Avogadro number into 5. What's your answer then? Like 1 by 4 into 10 power minus 1 into Avogadro number, we got methane molecules. This number into 5 is your final answer. Got this? Okay, that's it. Next, let us see few more questions. Yeah, try this question. Not getting? Which of the following contains equal to those in 12. So how to do? In 12 means how many moles you find? Just given weight is 12 by 12. No. What is the molar mass of magnesium? 24. So this is half mole. Half mole of magnesium. Then next, go through these options. 12 grams of carbon means 12 by 12, it is 1 mole. Next, 32 grams of O2 means 1 mole. Okay, 7 grams of N2 means number of moles of N2. See, actual answer is this one only, but how? It is what? That is what the important thing.
7 grams of nitrogen is the highest.
N2, number of moles of N2 means, take given weight is 7 by 28. So this is 1 by 4. 1 by 4 mole we got. Moles of N2 molecules we got. Molecules. Moles of N2 molecules. One molecule contains how many atoms? See, they are asking which are the following contains equal number of atoms as like 12 grams of magnesium. So 12 grams of magnesium contains how many? 1 by 2 into Avogadro number. So this one is molecule. In one molecule there are 2 atoms. That is 1 by 4 mole into 2 nitrogen atoms. Okay, 1 by 4 into Avogadro number into mole into means Avogadro number into 2 nitrogen atoms. So 2 times, so 1 by 2 into Avogadro number. Is this clear? That's it. That's why B. Okay, you can try few more questions. This one and also this one. You just take all these questions as homework. Remaining we will do in the next class.